All right. Now, the interesting thing about the general addition rule is that you only really need this rule. You don't need, scrolling back up, this one, the addition rule for disjoint events. So the thing about disjoint events is if they are truly disjoint, then what's true of E and F, i.e. the overlap? If they're disjoint, there won't be any overlap, and therefore the probability of E and F will be 0. So this general addition rule is the only rule you need. That said, if you want to write them both down on your formula sheet for your test, that's up to you. All right, now suppose a single card is going to be drawn from a standard 52 card poker deck. What is the probability of drawing a heart or a face? Okay, so let's write it out. Probability of heart or face. That would be equal to the probability of heart. I want to make that smaller so you can see it. Plus the probability of face. But you have to subtract the overlap if there is any. Heart and face, which there is. Let's talk about it. Okay, so how many hearts are there in a deck? There's 13 out of 52. Plus, how many face cards? Okay, face cards are any ones with faces on them, i.e. kings, queens, and jacks. We're not counting jokers because I'm just assuming the 52 card deck, not with 2 jokers. So there's 12 out of 52 because there's 4 suits and a king, queen, and jack in each suit. 4 times 3 makes 12. But the problem with that is that you've double counted. The king, queen, and jack of hearts, they're both hearts and they're face cards, so you've counted them twice. So you have to subtract them away. Right? And it's best if you leave it all out of 52 until the very end, right? Because that makes the subtraction and addition easier with fractions. So this makes a grand total of 22 out of 52. And of course you could find the decimal for that with a calculator or with Excel. All right, there's done with that. Now that's classical probability, just reminder. Oh, if I could spell. This was classical probability. Okay, and I think I spelled probability wrong. I'm just batting 1,000 today. All right, now what about this? Down here, this is the actual data. I contacted the Jackson, Michigan Red Cross. So this is the actual data for the Jackson region. It was a couple years ago, but it should still be good. So this is going to be empirical probabilities that we're going to be finding here, just in case you were wondering. And these are classical up here. I'll remind you. Oh, I cannot type tonight. Okay, so what is the probability of type A blood? Okay, well, if you're type A blood, you're either A positive or A negative, right? So if you want to be type A, that's equal to the probability of A positive plus the probability of A negative, which would be 0.3207 plus 0.0692. And I'm going to need Excel to do that calculation for me. Oh my gosh, I cannot type. 3207 plus 0.0692. Ta-da! 3899. Go away. Honestly, if I was going to be good about Excel, I should probably do this. Copy, paste it in there. It's going to take it a second. There it is. So A would be equal to the sum of these two guys. There we go, 3899. Now what about Rh positive blood? Okay, Rh positives is all the positives. So that would be equal to the sum of this one, comma, this one, comma, this one, comma, this one. All the positives added up. So 0.7979. It's the, hold on one second. There. I wrote it all out so you could see it. So it's the probability of O positive plus A positive plus B positive plus AB positive. And they're all for the numbers, and then there's the final answer at the bottom. All right, what about A or Rh positive blood? All right, I'm going to pause it so I can type it in real quick. There it is. It's A, probability of A, plus the probability of positive, which we found above, minus the probability of A positive. This was not a disjoint event, so you have to subtract away the overlap, which is A positive. All right, I'll pick up right here next time.